35 minutes before Gloria starts to do her glorious dance with the bell. We'll talk about something that has come up in the last, I would say, 4 years with a real bang and prominence. Something that was in the background for more than 25 to 30 years. And what brought that into prominence was the pandemic. Where do we go from there? Where do we see the future of us tackling pandemics? And I don't want to, as the title, if I can remember, it's not there, the lessons from the pandemic. So we won't be emphasizing or focusing entirely on COVID, but we will use that as a starting place to go beyond COVID and to look at the kind of diseases that afflict Indians that the rest of the world is possibly not as bothered to cure as the diseases that afflict them, especially Western nations. And I think there are a few points that, Shailja, we can start off with before we come to the specifics of mRNA vaccines and their future. So the first one is the obvious one. All of us remember December 2019, November 2019, and the journalists amongst you, and Shiv, of course, I remember his tweet about the Wuhan thing. I think it was November, if I'm not mistaken, when the real thing started. So the story kind of was like a tumbleweed in the later months of 2019, but then it exploded when WHO said that the virus is not transmitted, to humans. That's their iconic tweet. And I remember Shiv was one of the first ones who quote tweeted that tweet. I think he called WHO as Wuhan Health Organization. But then it reached it kind of, pierced the public consciousness. Before that, it was just another virus amongst thousands of viruses that, wreak havoc, sometimes not, afflict humans. You remember a couple of months ago, there was this monkeypox thing. Some news associations with diseases catch on and some don't. But that's the news part of it. The other part of it is the science part. And I think that's equally important, because it's not just that people thought, look, COVID story is important and it should gain prominence. It was the science and the devastation behind it that actually led to the entire news, and people now know. Yes, yesterday we were talking that, I think it was Mudit who asked the question that what is the perception of science in the common citizen now, and I think it's increased enormously because of COVID. Now we know what RT-PCR is, now we know what a virus is, now we know what a coronavirus is and what a pandemic is, so many other things. Treatment, vaccines, mRNA vaccine, other vaccines. So many things did not work. Everything was tried for COVID. So we know what things to try, plasma, so many things. But it all started in 2020. Let's put that mark as Jan of 2020. How prepared were we? We were not prepared at all. Absolutely not. And why? That's the next question. Is because we were so lazy and callous when the first pandemic struck us. That's before the social media age. There was no Twitter. I think there was no Facebook also. 2003, 2002, I think, when SARS-1 struck. Now, it did cause devastation, of course, to a very limited extent, not compared to SARS-2, as we know. And a lot of governments immediately gave grants to scientists and to pharma companies to make vaccines against it. But before the vaccines could be put to clinical trials, the virus went away. The virus disappeared, and lo and behold, as we trust our government, the grants also disappeared. The politicians said, "Arey bhai, virus nahi hai, vaccine bana ke kya karoge? Hatao isko." We know a couple of colleagues, in fact one in JNU, who got the vaccine grant, और suddenly कहते हैं बस अब किसी और में डाल दो इसको. अच्छा टीवी पे काम कर रहे हो, चलो वो कर लो SARS की. Had we made a vaccine against SARS-1, we would have saved millions of lives in the first phase of SARS-2, because the spike protein of both SARS-1 and SARS-2 are very similar, portions of them identical, and the vaccine that would have obviously killed SARS or not allowed SARS-1 to gain infection would have helped a lot in preventing the kind of spread of SARS-2 that we did in the initial month, even going forward a year. So that's the first lesson. Do not stop funding, do not stop doing science just because the pandemic has disappeared, because the pandemic never disappears. And right now, if we believe that we will never have another pandemic, we could not be more wrong. There is SARS-3, there will be SARS-4. The question is our preparedness. We did not have a single vaccine going into COVID-19. We didn't have a single drug against it. We tried hundreds. Both of us tried one. We were asked to get a grant for that. And we didn't get a grant, and then what happened after a month, it turned out there was a Lancet paper, and the drug that we had proposed repurposing against COVID, they said it works spectacularly against COVID.
From French?
From French scientists, yes. The bottom line is, we were not prepared. So going forward, we have a vaccine against SARS-2 now, right? Will it work against SARS-3? That's the question. Of course, it will not work perfectly against SARS-3, because it doesn't work sometimes at all against even SARS-2 later mutants. The vaccine that was made against the original SARS virus is hopeless against Omicron, So even the variant of the same virus, the vaccine is ineffective. The point being, at least you can have a stopgap arrangement, but at least we know how to tackle SARS-2. We have a few drugs that can work to a limited extent. Most drugs did not work. I think remdesivir is the one that actually works to a largest extent. Otherwise, so many others. Even Musk jumped in and said chloroquine is working, and then he said, so many. I think the other drug that he named was against river blindness. Ivermectin is working. The question is, going forward, do we need a vaccine? The answer is yes. Now, how do we go about making a vaccine against every disease? It's not a question of a vaccine against a pandemic. It's not a question of a vaccine against a pathogen that is causing a disease. The lesson that we need to learn is we need to make a vaccine against every possible pathogen that will create a pandemic. Even if there is no situation or scenario of a pandemic happening against that pandemic. We just need that. That is what preparedness means. So going forward, before we delve onto the other things, I think Shailja, it would be wonderful if you can give a nice background as to what is a vaccine and how does it work and why do we need a vaccine as opposed to a drug?
Yeah, so thank you, Anand. It's a nice introduction why we need a vaccine. Yeah, is it okay now? Yeah. So to start with, like when we already have disease, of course we treat them with the help of drugs and other things. But we want to prevent happening the disease. That time vaccine comes into picture because we just don't want the disease, what is around us. So in that case, to have the protection, the vaccine works. And how it works? Because basically your immune system, which is there in your body, you are training them to remember this is a pathogen which will cause the disease. So once your body is trained to detect the pathogen which is going to enter into your body, you are already prepared. The immune system of your body is prepared. So in that case, memory is there in your immune system. As soon as the pathogen or any per se disease causing element is entered in your body, your immune system has a check. It will detect and also clear it. So detection as well as clearance is being done by the immune system. How will you train your immune system? Because your immune system has not seen the pathogen yet. So you are providing the information in terms of DNA, RNA, protein, about the information about the pathogen to your body, and that's called the vaccine. So vaccination is that your immune system is now able to recognize and clean it from your system. So in that case, as already there could be many ways of making vaccine. For example, as we know, for SARS coronavirus, we have two types of vaccine majority. Like we can have the whole pathogen, we can weaken it, we can kill it. So the pathogen is in actual form, and you are just killing with some chemical inhibitors, you are killing them for irradiation, you are weakening it through some molecular biology, and that pathogen you are injecting to human body. Now it is not causing the disease, but your immune system now knows, okay, this is the pathogen, I need to be prepared myself. Second is that you don't need to have the whole organism, but you can have information from the organism, information from the pathogen. So what is the information? The information is the coding in that pathogen, which is there in its DNA or its genetic material like RNA. So in that case, you get the information in the form of DNA sequence or in the form of RNA sequence. Or you just want, okay, no need to do that, you have the information, make the protein, give the protein, which is a subunit vaccine. So like very known vaccine, polio vaccine. It's a whole cell vaccine. The virus be killed and given orally. So your immune system is trained. There are subunit vaccine where you are giving the protein and then you are challenging your body to recognize. Now comes the mRNA vaccine. Why the mRNA vaccine is good and why we need it? First of all, of course there are some challenges involved in the mRNA vaccine, but at the same time it's faster because you are just taking the sequence from the pathogen, putting it into the human body. And your body is making the protein out of that information, and your immune system is being challenged by that protein, and you are ready with whatever pathogen comes. You are
just to add a little bit for our background. So the dogma of life works that you have DNA, that's through your chromosomes. The DNA is coded and it's decoded into an RNA, and the RNA is then decoded into a protein, and the proteins are the ones that run your cell and everything. So DNA, RNA, protein. Central dogma of life. The DNA is in the nucleus. The RNA that is made escapes from the nucleus of the cell, goes outside but into the cytoplasm of the cell, and that RNA is then worked upon by ribosomes and other translated into protein. So the mRNA or the RNA is floating around in the cytoplasm and proteins are made through there. So the mRNA vaccine,
So yes, but I was just talking about the mRNA vaccine. It's not that easy. You know, the Nobel Prize 2023 Nobel Prize gone to Catalina and Wiseman. What they did, they just told that whatever mRNA or DNA you are making, which we call the nucleotide, which is the building block of that mRNA, even it can be seen as a foreign in your body. Let's say I am just putting an information to a human body, but the information is something which you require, but even the delivery method you are seeing as a foreign.
So here again, I'm like an inquisitive child. I speak for the audience.
Yes.
Because it's very interesting. You know, each question comes and it cascades into another question. Now, our human cell is so fiendishly clever. Otherwise, any virus, an RNA virus or something like that, would inject the RNA into the cell and nothing would happen. But our cell sees that even RNA as foreign and destroys it. So if you were to make an mRNA vaccine, you are injecting a foreign RNA, your body would destroy it. So the vaccine would not work.
Yes. So in that case, even the vaccine you have to humanize it. Meaning it should look to your body as your own, because information is there. And there comes the Nobel Prize work by these two scientists. What they did, they just modified the mRNA. Why they modified? They wanted this sequence of mRNA to be like recognized as a self. And then second thing, they also wanted it to be stable, because as soon as you are going to put the mRNA in the human body and I will just degrade it. So in that case, it is not going to help you. Third thing, even your immune system should not be provoked by that mRNA. And the fourth thing, the information should be properly translated. As he just said, from DNA to RNA, RNA to protein. If the RNA is not going to make protein, it is not going to work. So in that case, all the 3 points being taken care by the two Nobel laureates, where they could modify the mRNA. So you can see in this picture, where if you are putting just the mRNA vaccine, which is a unmodified form, it will just go and it will be degraded, one thing, and even the body of a human will see it as a foreign, and then it will evoke some unnecessary immune response. But in case of their discovery, they made some changes into the mRNA, and that mRNA is now recognized as a self. It will do its job properly. It will translate to the protein, and it will also evoke a very specific immune response which is required, like against the SARS coronavirus. And in our case, now we are trying to put the sequence for the malaria.